So if we look at the first thing that we're supposed to do, we're supposed to graph and write the solution set in both set builder and interval notation. So we have y is greater than 5. So when I look at this, I draw a little number line here, and I'll put a mark denoting that that's 0. Because we have y is greater than 5, we don't have greater than or equal to. That tells me we want to close an open circle at 5. So at 5 we have an open circle. So we're not including 5 in our solution set, we're just looking for numbers that are larger than 5. And because we're looking for numbers that are larger than 5, the numbers that are larger than 5 are to the right of it. So we shade this side, and that is the graph of this inequality right there. Now, putting it in set builder notation requires nothing more than this. We have y is greater than 5. You put a line here, you put a y here, that's the variable that we're referencing. Then you put set brackets around each side of it, and we're done. So this is a set builder notation for this inequality. If we're using interval notation, those are the ones with the parentheses and brackets. Because we have an open circle, we're not including 5, so we want a parenthesis, 5, comma, and because this goes off to the right infinitely, this is going to infinity, and that's the set builder notation. Now if we look at the second inequality, one thing that we could do is we could put this in set builder notation right away by putting a line here, an x here, and then putting set brackets around that. Now that's in set notation. Now if we're trying to, when we're trying to graph this, I'll go ahead and draw, I'll go ahead and draw a number line, and let's get some of that off there. So we have our number line right here. I'll put a mark at 0 so we know where we're kind of starting. Now this is an interval that starts at -5, and because we have greater than or equal to includes -5. So I'll make a little note. That's -5, and that's a closed-in circle at -5. So x is greater than this, so we're going to be going to the right. And then we're going all the way up to here where x has to be less than 2. So I'll put a little mark at 2. And this isn't drawn to scale, but you get an idea of what's going on. That's 2. Because we have less than, not less than or equal to, on an open circle. Shade that. And this is the interval that we're looking at. Now to denote this interval, it starts, because we're always reading these from left to right, it starts at -5. And because we're including it with the less than or equal to, and with the bracket, with the closed-in circle, we want a square in bracket. And we start at -5, the far left value. This is going all the way up to 2. And we're not including 2 because we just have a strict less than there. So that's the interval we're looking for there. Okay, so that's just getting an idea of the notation and what the graphs will look like. And it is a good idea to graph these solution sets. It gives you an idea as to what things look like. Okay. So now what we're doing is we're going to solve these, and we're going to state our solutions in both set builder and interval notation. Now, these inequalities are much like equations, except when we multiply or divide by negative numbers, we're going to have to flip the sign. So if we're looking at this first one here, y minus 9 is greater than -15, we want to get rid of -9, so we have to add 9 to both sides. So here, 9 and -9 go away, so we have y. We're not flipping the sign because we're adding numbers here. And -15 plus 9 is -6. So, once we've solved this inequality, that is, we've isolated the variable, we can put this in set builder notation by putting a line here, a y there, and then putting our set braces around it. Now, if we think about what the graph of this would look like, even though it's not asking us to graph it, y is greater than -6. We'd have an open circle at -6, okay, because we don't have greater than or equal to, we just have greater than, and because y is greater than 6, we're going to be shading to the left. Now sometimes I'll graph just to give me an idea what the interval notation on this would be. Interval notation, we're reading from left to right, we're starting at -6, but we're not including it, so this is going to be -6, and it goes all the way to infinity. So that's that one there. The second one here, we're going to try to isolate the variable as well, the x. So in order to isolate the x, we need to get the 3x alone. So I need to get rid of that plus 2, so I'm subtracting 2. Now when we're adding and subtracting to both sides of an inequality, we're not changing the sign. So we cancel there, we get 3x. This is less than or equal to. -4 minus 2 is -6. Finally, if we want to get x all alone, because 3x is 3 times x, we divide both sides by 3, and we get x is less than or equal to -2. So to put this in set builder notation, line, x, scribble, if we thought about what this would look like graphically, x is less than or equal to negative 2, so negative 2 is where the action's happening, because we have less than or equal to, closed in bracket, we're shading to the left. Now this will tell us how we do our interval notation, because we're reading from left to right. This is the interval that goes from negative infinity, way out here to negative infinity, all the way up to negative 2, and because we're including negative 2, we have a square end bracket, not a parenthesis. Okay. So moving down to this next one here. We want to get all the y's on one side, and we want to get all the numbers on the other side. So I'm going to get all the y's to the left. So I need to get rid of these negative 7y's. So if I add 7y to both sides, our 9 carries down. Negative 8y plus 7y is a negative y. That's less than. And over on this side we can combine some like terms as well. 5 plus 2 is 7. Our y's cancel off, so we have that. Now we need to get rid of our 9, so we're going to subtract 9 from both sides. That is a 9, in fact. So we get cancellation here. Now remember, we're bringing this whole term down, so we have a negative y is less than. Here, 7 minus 9 is negative 2. And then we need to get this y alone, so because negative y is negative 1y, do we divide both sides by negative 1? Because we're dividing by a negative, we have to flip the sign. So if y is greater than now, negative 2 divided by negative 1 is 2. So this is what we're looking for. X is greater than 2. To put it in set notation, line, y, scribble. And then the graph of this would start at 2, not including 2. And because y is greater than, it goes to the right. So putting this in interval notation, it goes from 2 to infinity. And that's that one. So we have the set notation, we have the interval notation. So moving on to this next one here. We want to get the x's on one side, the numbers on the other. So I'm just going to move the x's to the left again. So I'm subtracting 2x. 3x minus 2x is x. Our plus 18 carries down. Our x's here cancel. We have 16. Move the 18 over by subtracting 18. So the 18's cancel. When you get x is less than or equal to 16 minus 18, negative 2. So, once again, set notation, set builder notation. Put a line, put an x, scribble around it. That's our set builder notation. To put this in interval notation, I'll generally draw a graph. So I'm just, the point of interest is negative 2. So we have negative 2. Now, because we have less than or equal to, we want a filled in circle. And because we're less than, we're going to the left, which tells me that as we read from left to right, this interval goes from negative infinity to negative 2. And because we have less than or equal to, and we have that closed circle, we actually want a square end bracket around this and not a parenthesis. So really things that go together is less than or equal to, or greater than or equal to, closed circle, and square end bracket. Okay, so now we get these last two squared away, and then we'll be good. So, much like equations, this inequality, first thing we need to do is get rid of these grouping symbols, get rid of these parentheses. So we want to distribute our 7 and our 6. So distribution of our 7, 7 times 5x is 30, 5y is 35y. 7 times our negative 2 is minus 14. Greater than.
Yes, sir. What can I do for you?
6 times 6y is 36y. 6 times our negative 1 is minus 6. So after we have our distribution done, we have y's and numbers on both sides, so we want to move the y's to one side, the numbers to the other. I'll move the y's to the right this time. So subtract 35y. Subtract 35y. And the reason why I'm moving the y's to the right here is because they cancel here. Negative 14 is greater than. But 36 minus 35 is positive, so we have a positive y. So in the very end, we're never going to have to divide by a negative and think about switching the signs as long as we keep our y's positive. Our negative 6 carries down. We want to get that to the other side now, so add 6. So negative 14 plus 6, negative 8. So one thing I do want to say is negative 8 is greater than or equal to y. That's the same thing as saying y is less than or equal to negative 8. Notice, is the pointy piece poking into the y here? Yeah. Is it poking into the y there? Yeah. Is the bitey piece biting the 8 there? Yeah. Is it biting the negative 8 there? Yeah. So these are equivalent statements. But it kind of looks better. The second one is how students generally see that. Now, putting this in set notation, put a line there, put a y there, and scribble. And then if we want to put this in interval notation, go ahead and draw the graph. Negative 8 is where the action is, so where y is less than negative 8, put that at negative 8, open circle, and we're shading to the left. So this is going to give us the interval negative infinity to negative 8. And now, because we're not including negative 8, because of our less than, our open circle, that gives us a parenthesis we want there. Okay. So, let's do this real quickly. Let's erase our line there. Oh, no, it won't like me to erase it. So we got this last one. We have negative 6/5 is greater than negative 4x. So here, think about this. Negative 4x is really negative 4 over 1. And generally, to get rid of these things, we can multiply by the reciprocal. So, multiply by negative 1/4 here. And the reason why I turned this into a fraction is because we have negative 6/5 the fraction. So when we work with fractions, it's easier just to have everything as fractions. So I'm multiplying this other side by negative 1/4. Now one thing is this. We're multiplying by a negative, so we got to switch the direction of the sign. Here, 4 cancels with the 4, 1 cancels with the 1, negative cancels with negative, and we get x. Over here, negative and negative is a positive. We can cancel a 2 in there and a 2 in there, giving us the 3 and that. So here we get 3/10, or 3/10 is less than or equal to x, which generally doesn't look good to most students, so we'll write this as x is greater than or equal to 3/10. To put this in set notation, put a line in x and scribble. And similarly, if we wanted to get this in interval, generally I draw the graph. X is greater than or equal to 3/10. We know we have a closed-in circle because we have greater than or equal. We'll say this is at 3/10. X is greater than it, so we're going to the right. So this, in interval notation, would start at 3/10 because we're always reading from left to right and go to infinity. So hopefully that made sense. See you next time.